Okay, so good morning, everyone. Good night for some of you. So I'm happy to present my job market paper, Dynamic College Admissions and the Determinants of Students' College Retention. This is joint work with Ignacio Rios from UT Dallas Operations Research. Interrupt me whenever you want. We know higher education is both valuable and scarce, but at the same time exhibits very low retention and all-time graduation rates. According to the OECD, only 40% of bachelor students graduate by the theoretical duration of their programs. And this is heavily affected by the fact that many students switch either their majors, their colleges, or drop out during their college progression. Now, at the same time, several countries organize their college admissions via centralized assignment mechanisms. So this raises the following research question. Can centralized assignment mechanisms affect students' outcomes, such as their decisions to drop out and switch majors or colleges? And how should we redesign matching markets in order to improve agents' outcomes? There is actually quite scarce evidence about the potential effect of assignment mechanisms on students' outcomes. And one of the main reasons behind this is that to really address properly this question, we need to understand carefully what are the determinants of students' dynamic decisions and how they may be affected by the design of the market or the matching system. In the paper, we're going to conjecture the existence of mainly two behavioral channels that can explain student switchings and dropout choices. One, the learning channel. Students might be learning over time about their match qualities with programs through their experience. Upon receiving new information, this could change their future labor market returns, and that's why they decide to switch, drop out, or continue their enrollment. But it's also possible that even in the absence of learning, students are switching or dropping out because the assignment mechanism generates initial mismatches. Let me define it. If students have dynamic considerations when they apply to college, knowing that they can retake exams or reapply in the future, and they also face some uncertainty on admission chances, the following can happen. Students who are initially not assigned to their top choices can still face incentives to enroll into those programs and then retake exams, reapply, and switch to more preferred programs. The problem is that if the system is in excess demand and colleges care about retention, this behavior generates a congestion externality, which introduces an inefficiency in the assignment. It might be ex-ante inefficient to assign some of these students not to their top choices if they face low retention probabilities. So the big picture of this project is to understand how to design matching markets where all these features are present and correctly balance the gains from learning through experimentation, allowing students to switch in some cases, but also trying to reduce the congestion externality produced by inefficient switchings and the initial mismatches. How are we going to tackle this question? We're going to build the first dynamic structural model of students' college progression in the presence of a centralized admission system. The model will capture the application behavior of students, as well as their decisions to retake exams, reapply to the system, switch programs, drop out, while they learn over time about their match qualities with program through their college grades. We will use the structural model and the data to disentangle both behavioral channels. And then we will evaluate policy changes that aim to reduce initial mismatches by eliciting the intensity on students' preferences, increasing the fraction of students who are assigned to the top true choices. We do this in two ways. One, by changing the assignment mechanism, introducing trade-offs in the application process. And two, for the first time, empirically evaluating incorporating dynamic incentives in college admissions by reapplication rules. The trade-offs that we face is that in the first case, we may, of course, introduce some strategic incentives. So this is a margin we have to take into account. In the second case, we might increase exposed mismatches if we want to reduce initial mismatches. The main results of the paper are that close to 1/3 of switchings can accrue to the initial mismatching channel. And simple policy changes, such as allowing students to signal a unique choice in their application list, similar in spirit to the signaling mechanism of the econ job market. Receiving a score bonus for that signal can reduce switchings by close to 17% from the baseline while achieving the same level of welfare. The main contribution of the paper then is the evaluation of centralized college admission systems on outcomes beyond initial assignments, but also taking into account dynamic considerations of agents and allowing them to learn over time about their match qualities. We're going to analyze for this paper the Chilean semi-centralized college market. In Chile, students apply to programs which are combinations of majors and universities. Every year, students can take a set of national exams who are called the PSU. And then after they receive their scores, they can submit their application list or rank order lists with no more than 10 programs in the list. We look at Chile primarily for the following reason. Chile uses a variant of the DA algorithm, which we have shown in another paper that is strategy proof in the large for students. However, some students are still behaving strategically in the Chilean system. What they do, even if they don't face the constraint in the length of the list to be binding, is that they skip programs that they believe are out of their reach. So this creates an identification threat, and I'm going to explain you how we deal with that. In terms of dynamics, students in Chile can retake the national exams and reapply to the centralized system every year if they want. They can save their PSU scores for 2 years without retaking the exams, and close to 30% of students switch programs, typically delaying their graduation, and close to 30% drop out. So it's also policy relevant to analyze these issues in the Chilean system. The data that we will use is going to be administrative data about the admission process of Chile, enrollment data, data on college grades, and aggregate labor market data, such as average wages at the program level. And to deal with the problem that students are behaving strategically, we're going to design and conduct 2 nationwide surveys to elicit information on students' top true preferences for programs and their subjective beliefs. I will explain you later on how we use this data to identify some model parameters. Now, a quick high-level overview of the model. This is going to be a dynamic discrete choice model of students' college major choices or program choices. Students are going to be forward-looking, to have persistent and idiosyncratic preferences at the major and college level, which will capture this unobserved portion of the preference intensity of the student. And they will also learn over time about their match qualities with programs. We're going to model the unknown portion of match qualities as multidimensional abilities that vary at the program level by the subject requirements of the program, how intensive it is in math and verbal skills, and at the major of the program. Both preferences and abilities can affect students' achievement and labor market returns, and that's why they switch or drop out after learning about their abilities. Students will update their beliefs about their multidimensional abilities in a Bayesian fashion, and will have a common prior over the ability distributions. In the first stage, students, after they observe their scores and their preference shocks, they can make application decisions or rank order lists. So they don't choose enrollment choices immediately, they choose application choices. We're going to allow students to come from a mixture in the level of sophistication. So a fraction of them will behave as naive, weak truth tellers, and the remaining fraction will behave strategically, as the data shows. What they will do is that they will skip programs that they believe are out of their reach. We're going to use the surveys to identify these fractions. After students apply, they receive their assignment and make enrollment choices. And then during the academic year, they can choose to retake the PSU or not. And if they enroll in college, at the end of the year, receive their college grades. College grades will be noisy signals about students' unknown abilities. So students will update with these signals their beliefs about these components. And then we allow stage 1 to repeat. So we allow students to reapply to the system, switching, dropping out, or continuing their enrollment. After period 2, students are going to face an exogenous sequence of dropout and graduation probabilities that will match them to the labor market, and students who graduate enter the labor force and receive the discounted present value of future average wages and also a non-pecuniary value for the labor market. Now, the main question here is how can we possibly separately identify these two behavioral channels when we observe switchings? So the learning channel is particularly captured in the model by the parameters governing the distribution of the noisy signal, that is college grades, and the parameters governing the prior beliefs of students about the ability distributions. So intuitively, the data that we exploit here is going to be correlation between the signal, college grades, and student outcomes, their switchings and dropout decisions. And also, we're going to exploit the fact that we observe in the surveys students' true preferences and how they vary over time. For the initial mismatching channel, this is captured primarily in the model by the parameters governing the idiosyncratic and persistent preferences at the major and college level. They will trigger the initial mismatching channel. What we will exploit here is the fact that we observe students' initial preferences before they have observed any college grade and updated their beliefs about their match qualities. And also, we're going to exploit the fact that the assignment mechanism generates some exogenous variation in the preference of assignment, which changes incentives for students to switch even in the absence of learning. So let me give you one example here. In the first channel, in the learning channel, we're going to see, for instance, students who are, even if they're assigned to their top choices, then if they receive lower grades than expected, they are going to be significantly more likely to switch to programs that were not initially listed in their application list. For instance, switching their majors or to programs with different subject requirements. In the second case, for the initial mismatching channel, we're going to see, for instance, that students who are not initially assigned to their top choices, let's say nursing, regardless of their college grades, they are going to be significantly more likely to switch up the ladder in their initial preferences. For instance, switching to medicine. I will show you now the empirical facts and what are the variations that we exploit in the data to identify the parameters of these different behavioral channels.
Can I ask fast clarifying question? So how you categorize those who, for instance, got their top choice and then they learned that they're actually too good, and then they decided to switch because they found, that they are actually good enough for a better college. So this would kind of be in line with your learning channel, or is it mismatch? In a sense, it's driven by mismatch because I had wrong beliefs about what I can get, but apparently now it's better for me to switch to a better college, just in terms of rank.
Yes, yeah, it's a good question. So, of course, every switching is going to be affected. Switchings are going to be confounded in the data and affected by both channels, right? It's not that there exists a switching that is accrue only to learning or only to initial mismatching, right? So we're going to use the structural model to discipline how much of these switchings are accrued to one channel versus the other one. So the model disciplines exactly how much of that type of switching is true what you're saying. Not every switching up is due only to initial mismatching. There are switching ups that, of course, are also affected by the fact that the student learns something about his grades. So some consistent data patterns that the initial mismatching is here. We're going to exploit the fact that the assignment mechanism generates a set of admission cutoffs. So we can run regression discontinuity designs around these admission cutoffs and estimate the causal effect of not being assigned to your top true choice. Here I'm showing you in the left panel how not being assigned to your top choice increases the probability of reapplying to the centralized system by close to 100% from the baseline value, close to 15% in absolute value. And in the right panel, I'm showing you the probability of switching that increases in close to 23% from the baseline value. Where are students switching to? Close to 50% switch to initially more selective programs. And between 25 and 50 move up in their initial preferences. So these switches could be explained by the initial mismatching channel, even in the absence of learning. For the learning channel, we're going to exploit the variation that we observe in the surveys. We had two surveys, two waves. So we compute that there is actually close to 60% of reapplicants declared to have changed their top true preference for programs. And we know exactly how these changes happen. Also, we're going to exploit the fact that as in the model, students are learning about their match qualities through their college grades, we're going to explain the correlation between the signals or college grades and the different types of switching. In the left panel, we see the probability of switching up in the y-axis, that is switching to a program listed initially above your current assignment as a function of your college GPA in the x-axis. We observe almost no correlation for the switching ups. So, as the previous person was inquiring, actually the data does not support much that students who are switching up because there is a positive correlation with their grades, right? But on the contrary, on the right panel, we see the probability of switching out, that is switching to a program that was not initially listed in the application list of the student as a function of college GPA. And we see this negative correlation quite strong. So students, when they receive lower grades than expected, they tend to switch to programs that were not initially listed. And that usually implies that they are going to switch either their major or to programs within the major, but with completely different subject requirements. For instance, less intensive in math. So these are the correlation patterns that we exploit for identification. Estimation, just a high-level description. We're going to estimate the model in a two-step procedure. First, we will estimate all beliefs from the data. The only non-standard procedure here is to estimate beliefs on admission probabilities, for which we use a bootstrap procedure of Larroucau-Rios 2019 that extends Agarwal and Somaini 2018. And then after we estimate beliefs, we're going to estimate the structural model parameters via indirect inference. The model has close to 80 parameters. So here I'm going to show you only the most relevant ones. First, we estimate that close to 90% of the students behave as strategic students, skipping programs that are out of their reach. So close to 10% are going to behave as naive weak truth tellers. This implies that some students are going to make strategic mistakes also. We're going to treat these carefully in the counterfactual experiments. For the mismatching and learning channel, we find quite strong preference persistence at the major and college level because the variances are quite high. And also we find that students tend to learn more about their match qualities with the subject requirements than with the major of their programs. After we estimate the model, we shut down the initial mismatching channel. And if we do so, we're going to decrease switchings by close to 1/3 from the baseline. This would translate into an increase of 32% of on-time graduation rates. So there is scope for improvement in the system if we can reduce some initial mismatches. I can give you more details about what we do here at the end of the talk if you want. Let me now go over the counterfactuals and then I'm gonna conclude. We're going to do two types of counterfactuals. First, changing the assignment mechanism, either constraining the length of application lists, which will introduce an opportunity cost on which program to include in the list. Also allowing students to signal one choice in their application list and receive a score bonus for it, which will introduce an opportunity cost on which program to signal. Both of these policy changes aim to elicit intensity of students' preferences, assign more students to their top two choices in equilibrium, and therefore reducing initial mismatches. And the second family of counterfactuals will introduce dynamic incentives via reapplication rules. To the extent of my knowledge, this has not been evaluated before empirically in the literature. There are two dynamic reapplication rules that we will evaluate. The Turkish switching score penalty rule. In Turkey, when students try to switch programs, they get penalized in their application score. What this mechanism does is that it decreases the continuation values of switchings, decreasing initial mismatches at the cost of increasing switching costs and exposed mismatches. And the second one is the first-time applicant score bonus from Finland. In Finland, when students apply to college, they will receive a score bonus, but only the first time that they apply. This increases the continuation value of the outside option, which means delaying your initial application and also elicits intensity. What are the results? The summary is the following. The first panel, panel A, we're going to first assume that all students behave strategically in the counterfactuals. If all students behave strategically in the counterfactual, we see the following. In blue, we have computed students' welfare as proportional changes in future wages of students relative to the baseline scenario. And in green, we have computed college retention rates. That is a composite of switchings and dropout rates, the inverse of that. What we find is that both the signaling mechanism and the first-time applicant score bonus with appropriate bonuses can both be quite effective at increasing college retention rate and also achieve higher welfare relative to the baseline. The switching penalty rule from Turkey seems to be the most effective one at increasing retention, but sadly this comes at the cost of decreasing students' welfare. And constraining the length of application list, even for the optimal value, seems to not be very effective at changing students' outcomes, but can increase a bit students' welfare if all students behave strategically. But now what happens if we actually relax this assumption and we assume that all students behave as naive as in the baseline? This is panel B. 10% of students behave as truth tellers. Still, the signaling mechanism and the first-time applicant score bonus seem to be more effective than constrained deferred acceptance with 10 programs. That is a baseline scenario. However, if we further constrain the length of application lists, we're going to get dire consequences on students' welfare because we introduce too many strategic incentives that are too high. So let me now conclude, and then I can take questions if you want. The takeaways of this paper are the following ones. We have analyzed the trade-offs of designing matching markets, where agents can have private information about their preferences, which can affect their outcomes. Learn over time about their match qualities through experience, and also face dynamic considerations, such as knowing when to apply, reapply, enter, and exit the market. The key insight here is that in order to design properly a matching market, we need to correctly balance the gains from learning through experimentation versus reducing the congestion externality generated by these initial mismatches. And this is sadly setting specific, so it has to be also empirically evaluated. Besides this, that can be applied to many other matching markets, not only college admission systems. We have analyzed, of course, in detail how centralized college admission system can actually affect and improve student outcomes if we redesign them. And we have shown that if we elicit the intensity of students' preferences in a proper manner, either by leveraging the dynamic incentives students face in their college progression, or by allowing them to signal their preference intensity through the mechanism, we can actually improve their outcomes, reduce inefficient switchings, not at the cost of their welfare. Sadly, lack of sophistication undermines both efficiency and welfare gains. So it is important that if we're going to move on or move beyond strategy proofness and try to leverage this information that matters for outcomes, we're going to have to implement also information policies that can help students to submit optimal applications. Where I'm actually with some co-authors running an RCT in Chile, exactly doing this. We are going to try to have the draft of this paper in the following weeks. Finally, for future research, it would be interesting, of course, to evaluate changes in the learning environment, right? Like changing the college structure to speed up learning and to analyze how these changes could interact with market design. So that's all. Thank you very much. If there is any question, I think we have 1 minute and a half or so. You can reach me whenever you want.
If I may, I would have actually two questions. One is that whether you have investigated the effect of, like in the US, you know, the programs are much broader. I mean, specification than in Europe. Like in Hungary, it's very much specified what is the university program about. So whether you see less or more switching in the US than in Europe, that's one question. The other is whether you have thought about also financial incentives. So for instance, in Hungary, 2012, the government introduced a strict limit on the number of years you can study for free, which means that if you switch, then you will lose, you know, some time and you have to pay tuition fee later on. So I suppose that this policy can affect the switching, especially for the poor students. So anyway, just 2 questions I wanted to ask.
Yeah, thanks, Peter. Great questions. I don't know if we have actually time for the answers or not, Alexander.
Please stop sharing your slides, and then Rustam can upload, and meanwhile you can answer the question.
Okay. Thanks, Peter. So for the first one, there is also quite a lot of switchings in the US. The key trade-off here is that when you choose a program, typically you're going to have, when you switch, you restart your education. So the effect of delaying your graduation is more severe in the type of systems like the European one or the one in South America. The US one is a bit different, but still students delay their graduation when they switch majors. And for the second one, that's a super interesting question. I have not actually analyzed that in this paper. It could be interesting for future research. We can talk about it later. Thanks.